Hi everyone, good afternoon. My name is Swagata Ashwani and I am a senior data scientist with Boomi. Today I'm going to talk about a very interesting and a very common topic. It's about creating custom vocabularies for NLP tasks. I'm really excited to present at the NLP Summit and share my thoughts on this very common topic, and hopefully, it will give you more insights on how to deal with certain situations when you don't have the ideal vocabulary and can create your own vocabulary. So, without further ado, let's start with the session today. So, for today, the agenda would be as follows. I'm going to start off with giving you a little bit background about myself, how I started my journey into data science, and what I do on a day to day basis. And then we're going to jump right to the crux of today's session, which is about custom vocabularies. So, first, I will start with explaining what a vocabulary is in NLP setting, and then talk about scenarios and situations where and why we would need those customs vocabulary and create a custom vocabulary. Then I'm going to talk about what are the different ways of adding them and which one would we take for our particular use case for today's session. After that, I'm going to talk about the two steps that are going to be followed for adding that vocabulary. Step one would be downloading a natural language model, and then I will walk you through how we can do that. And the second step would be to actually increase the vocabulary and customize it for your use case. That would be the second step. Then I'm going to walk you through a SpaCy approach. SpaCy is an open source library, which we will talk about, and how we can use it for this use case. And finally, to wrap up the entire session, we'll go over the entire steps that we took into account today and how it end to end works. Finally, I would give 5 to 7 minutes for any questions and any thoughts that you would like to share, and also share my socials so you can connect with me later after the session as well. So let's get started. About me, as I mentioned, I'm a senior data scientist with Boomi. Boomi is a iPaaS integration provider. I've been here for almost 10 months now. Prior to this, I worked in Amazon and couple of health insurance companies. I got my master's degree from Carnegie Mellon University and have around 6 to 7 years of experience in the field of AI, NLP, data science in general. I've also been in India for prior to coming and moving to US. I was working with a company Deloitte. I was working as a data consultant there and was working on Java and using data analytics on top of that for different vendors. On my spare time, I really like to work and look into the latest state of the art tech stack with NLP and do a little bit of research. Also, on the spare time, I like to play music and play guitar. So that's something I really like to do. Okay, so let's get started with today's session. First things first, what is a vocabulary in an NLP task? So, when we talk about NLP context, right, we often hear the term corpus. So, what exactly is corpus? So, corpus actually refers to the set of text that is used for the task. So, for example, if you have a task of, or you're trying to build a model which is analyzing all the Wikipedia articles in the any Wikipedia article that exists online. So your corpus would be that entire set of Wikipedia articles. But what I actually essentially need would not be that entire corpus. I would need to get the set of unique terms. So I take the corpus that I need for my use case and get the set of unique terms or words that I used in that corpus and create something called as vocabulary. So, vocabulary, to summarize, is nothing but a set of unique words used in a text corpus. So, now you might be wondering, like, we have vocabularies, we have these zillions of pre trained models which come with so many existing vocabularies that encompass all of the commonly used terminologies. So, why would we need to create a custom vocabulary? So that is because you have English language model and you have so many terminologies and Wikipedia articles and books and everything. But in certain circumstances, you might have certain terminologies that are related to, let's say, a medical use case or a legal use case. Or let's say you have terminologies that have been recently added, like, for example, COVID 19. That is a term that has been recently added and that might not be available in the prior vocabularies. So, in those kind of situations where you have a particular domain specific use case that you're trying to solve, or you want to add terminologies, or even if you want to assign more weight to particular terms, in that case, you might need to customize your vocabulary. So, that's why we need a custom vocabulary. So now going over, now we understand like why we need a custom vocabulary and what a vocabulary is. Let's go over the two straightforward ways of how we can add the custom terms and what would be the approach. So the first way I could think of was, you just fine tune on a new corpus and that's already trained on a natural language model, and you don't modify its tokenizer vocabulary but only tweak its embeddings. So this is a great approach. It's easy, it's straightforward, but it has its drawbacks or cons. Because it's so easy, it might have that the embeddings do not match the format, or it might have the tokenizer is of a different format, and it can lead to the vocabulary being not similar, and it can lead to a lot of errors. So the second approach is training from scratch on a new corpus, a new language model. So this method, although it's not error prone, it's gonna work completely fine. But the problem with this approach is that it's gonna be extremely computationally expensive and time consuming. So both of these methods are great and can work for certain situations, but they are on the extreme ends. We might want to find something in the middle, which will be more efficient and less error prone. So the new approach that is introduced in this presentation, and it's been widely used recently, it's called XBERT. I've attached the link to this paper where this was introduced. Basically, this method talks about fine tuning on a new corpus, an already trained natural language model, by adding to its existing tokenizer vocabulary that is specific to the domain. So instead of tweaking just the embeddings, you're adding to the vocabulary, but you're only adding the new terms or the specialized terms that you're wanting to add for the custom vocabulary. So this method is efficient. It's going to take care of any errors that can happen. And yeah, it's going to save you time and money. So let's look at this approach in detail now. So, since we are talking about XBERT, so its origin obviously came from BERT, which is a common language model that we've seen and used a lot. So, for this example, we are going to use BERT. So, the step one of this process would be to download a natural trained model, and we'll be using BERT. The second step would be to increase its vocabulary by adding those custom domain specific words to this model. Okay, so step one is downloading a natural language model. So, a lot of you would be familiar with Hugging Face. Hugging Face offers a lot of these pre trained models, so many of them that instead of creating your own, you can just download it from Hugging Face and then tune it and scale it and use it however it fits your use case. So, we're going to take the BERT base uncased model from Hugging Face. So this is the link that I used for my use case. Download it and save it in a model keyword. I've used the BERT base uncased, but you can feel free to use any other variation of BERT or even try to explore your own language model. So that is it. That is step one. Very easy, very straightforward. Now, step two, which is the main crux of this presentation, it's increasing the vocabulary to make it your own custom vocabulary. Now, again, I'm going to refer to something, a function from Hugging Face, which is called tokenizer.addTokens. This function is used to add the list of words to the tokenizer's existing vocabulary. So if you have a list of words that are specific to the domain that you want to add to this existing vocabulary, you can just pass it as a list into this function and it will be added. And this also ensures that if the words are already present in the existing vocabulary, it will not be added. It's only going to add the new words that are not present. So that's it. Is it that straightforward? Let's see. So BERT actually uses a word piece tokenizer. A word piece tokenizer is a tokenizer which takes care of subwords and words, both of them. So a subword is basically some set of characters which is found in one or several of the words. So if that subword does not match the start of the word, it will begin with double hashes. So for example, the BERT vocabulary that we downloaded did not contain the word COVID. So instead of that, it tokenizes it into subwords. So from the word COVID, we actually got three words, three subwords, which is three tokens. That is CO, then hash hash VI, because it adds two hashes. And then the third one is hash hash D. So thanks to this tokenizer.add tokens method, it's easy to insert a word like COVID into the existing vocabulary. So now let's see if it's actually able to understand this word COVID when we add it. So now we are trying to test and see that the new token that we are trying to add, which is a custom token, COVID, gets actually added to the vocabulary or not. So in this example, we've taken the new token as COVID. You can add as many terms in this list as you would like. For the simplicity, I'm just going to add one token for now. So I'm adding COVID, and I also need to pass the size of this new vocabulary into this resize token embedding, so it ensures that the size of the embedding is taken care of. So I pass that length of the tokenizer into this model.resize token embeddings, and then I would just tokenize it and print. So as you can see, it's able to identify and print the token, entire token COVID here. So that makes sense, that is working. Let's test it with few more examples to see if it actually works or not. So because of the subword tokenizer nature of this BERT, there could be a potential problem, right? So to understand that problem, we're going to go over one more token and understand this. So let's add few more tokens. So in the prior example, I was just looking at one token, which is COVID. But in this particular example, I'm going to look at all the set of tokens in two articles. These are two Wikipedia articles which talk about COVID-19 and COVID-19 pandemic. So this particular exercise is going to scan through these entire articles from COVID-19 and COVID-19 pandemic wiki pages and get a list of all the tokens. Now, keep in mind that we are using the BERT word piece tokenizer, which is going to look at the subword and word as well. So here is where we would get a sense of how the subword tokenizer can actually go wrong and give us incorrect results. So let's take the tokens into this token keyword. And again, as part of the prior exercise, we need to resize the token embeddings and pass the size or the length of the new tokenizer. So we pass that and then we print tokenize for two words. I mean, we have a list of tokens, but now we're going to test for two specific words, COVID and hospitalization. We know that the word COVID worked fine from the prior example, but we want to test the word hospitalization, right? So COVID looks good, but the tokenization of hospitalization did not work at all. As you can see, there are a lot of words which don't make sense, and there are a lot of words which don't even have a double hash. So, if we keep digging in and look at more and more examples like this, we would find out that the subword tokenizer actually doesn't work well. even though it worked well for COVID, it might not work for majority of the tokens that you have. So this is the reason that the word piece tokenizer would not be the ideal choice, and we would have to look at some other kind of tokenizer to make this thing work. So now that we understand that this tokenizer will not work, we would need to use some other tokenizer. And what's the solution? It's SpaCy tokenizer. So SpaCy, as you might have heard, is an open source word tokenizer. It's used to find new tokens and does not look into the subword tokenizer. So this is an extremely useful, handy, open source available tokenizer that you can use for your use case and create new tokens and find new tokens without having the issues of running into subwords or those kind of problems. So we're going to use the SpaCy tokenizer now for this use case and see how similar exercise what we did in the previous slides, apply the SpaCy tokenizer and see how it works. So, what are going to be the steps? First step would be to initialize the SpaCy tokenizer with the general vocabulary of the language model. So, as we did in the prior slides, we're going to get the general vocabulary of the language model, and we're going to use the SpaCy tokenizer. So, once we get the general vocabulary, the next step would be to get the list of tokens of the document, and the next step would be this is going to be getting the IDFs. So IDFs are inverse document frequencies. So basically you want to use the scikit library to get the IDFs and use it for getting a sense of what are the most frequent to least frequent tokens that are used in the document, and decide for yourself whether you want to use all the most frequent tokens or you want to use just a proportion of it based on the IDF values. So now that you have the IDFs, now you can arrange these tokens from most frequent token to least frequent uh, token in the document. And the next step would be you can figure out, I just want like the top 5 most frequent, or I want to use all of them in my custom vocabulary. That's up to you. And depending on the use case, you can decide and tweak it. So once you have the list of new tokens that you would like to add to the general vocabulary, you would then add these new tokens that will represent your specialized vocabulary and enrich your existing vocabulary by adding them. And as always, you always resize the model embedding so it matches the tokenizer. So these are the high level steps. Let's see. So let's go over the pseudocode on a high level now. So we did the prior slide steps one by one, and we want to compare how our SpaCy tokenizer performs compared to the prior tokenizer. So in the prior step, we did tokenize, and text. And in this one, we are using the XBERT approach. So once we print the total number of tokens, the length, we can see the comparison. So in the prior approach, we had 203 tokens, but in the new approach, we only have 193. And you can realize that as you scale up and go with higher number of tokens, this difference is only gonna get higher and higher. So we can see with the SpaCy, the expert approach, we are able to get lesser number of tokens, and it's going to take care of that subword issue that we had. Okay, so now that we've understood the benefits of using SpaCy and how we can use and create our own custom vocabulary, it's time to just revise and summarize the entire steps end to end. So for this example, I'm going to stick to a Spanish language model, but you can take any language model and experiment for your own use case. So the first step is, as usual, import the libraries. And the second step is you initialize the tokenizer with Spanish, Portuguese, English, any SpaCy tokenizer. And then you define the SpaCy tokenizer and apply it to your scikit so that you can get the IDF tokens of all the tokens. After that, you sort them from most frequent to least frequent, and then you decide whether you want to use all the tokens or what proportion of the new tokens you want to add to your general vocabulary. The next step would be to import a Spanish model and tokenizer. Feel free to change it to any other language model, and then add these new tokens to the existing vocabulary. And again, it's only going to add the words that are not already present in the existing vocabulary, and those that are not present are added. Those that are present that are not added. And obviously, it's going to take care of your subword situation, to only the actual tokens or actual words are going to be added. And as the last step, you are going to work on resizing the embeddings so that the tokenizer is uniform. So, yeah, those are all the steps. So, today's exercise, we actually went through understanding what is a vocabulary, and then we went over why we need to use a custom vocabularies in what situations, and then we went over the two-step approach about how to add a custom vocabulary. The first step being downloading a natural language model. We used BERT for our example, and then we went over the second step, which is the crux, which is going over how to add these additional terms. And we realized that in order to customize and add these additional terms, there is a problem with the BERT tokenizer, because it takes a look at both subwords and words, so it can cause problems in the tokenization. That's why we switched to SpaCy tokenizer, which is an open source tokenizer, and we saw that how we can use SpaCy tokenizer to reduce our number of subwords created, and it's only looking at the words, not the subwords, so it's able to perform in a more efficient way for our use case. And finally, we looked at how we can resize the embedding so that we can use it for a future purpose. So yeah, once you have the embedding matrix of the model, then you can use it for any NLP task like prediction, text generation, chatbot, and whatnot. So yeah, that's the ending of this session today. So once you have the embedding matrix, you can further use it for your own NLP tasks. And that's how you create a custom vocabulary and use for any NLP task. Yeah, I would like to save the last 5 to 7 minutes for any questions, thoughts, and anything that you would like to share, anything that was not clear, and also share details about how you can get in touch with me. I would love to talk more and chat more if anybody has questions, anybody would like to collaborate. So I hope you found this session useful, and I would like to share all the material and the slides with you so you can refer to it and get back to me at any point of time. Thank you so much.